This weekend to a small group, but feel free to come a little bit closer if you can't hear me or if you want to see the slides in a little bit more detail. So thanks for that introduction. As Chris mentioned, I've been working in the space of analytics for about a decade now. First at Deloitte, Economic and Statistical Consulting, and then various e-commerce companies, PayPal, eBay, and Hotwire. And it was great for me to actually start in the consulting world because I was working with a bunch of PhDs who have been using econometrics techniques for the same type of problems that data scientists actually use their techniques for. In fact, a lot of the data science techniques really take root in the econometrics techniques that we developed in the 1970s. Along the way, I also invested into Beyond Core, which is a software solution that automates a lot of the analysis that we do manually in SAS and in R. So it takes some data, processes it without any need for statistical knowledge or coding knowledge, and then outputs a Word document or a report in PowerPoint. So I'll talk a little bit about how we use it in different companies. So if you work for a decade in any space, you make a lot of mistakes, or at least you observe people making lots of mistakes. And that's exactly what the presentation is going to be about, right? It's better to learn from mistakes than from things that they tried. And based on those mistakes, of course, I took away some lessons and derived 3 principles that I use when I choose what type of projects my teams focus on, how we prioritize the work of our analytics organization. I'll talk about various cases spanning the customer journey, including the acquisition efforts and how do you actually prioritize investments into the acquisition efforts, customer engagement, pricing, cost management, which is, of course, a very important component as well, with some of your customers being really big drivers of your costs. And then finally, retention. So let me start by sharing with you the first ROI maximizing principle of any data science or analytics efforts, and that's really understanding and evaluating choices. It sounds very intuitive, but actually that's not what we often start out with when we hear of a problem that a business stakeholder is facing. We start with descriptive analysis, we boil the ocean, without actually understanding the type of treatments that the business user can deploy, or the type of decisions that they can take based on that information. And there's a wonderful quote from Jan Rifkin. How many of you have heard of him? A couple of people. So John Rifkin is a professor of strategy at the Harvard Business School. How is it related to data? Well, he actually talks a lot about using data in strategic decisions. And what he has observed is a lot of companies boil the ocean when it comes to data analysis and leveraging data analysis for making strategic decisions. And so what he is recommending is, instead of boiling the ocean, you should translate that problem into choices, whether to go after small merchants or large merchants, whether to go after these merchants first or other merchants later. And then as you frame the problem as a choice, any choice, your analysis and emotions will focus on what to do next, and really on narrowing that analysis program. So it's all very abstract without an actual example. So let me move on to the first case where we made lots of mistakes by not focusing on the choices of treatments and deriving the analysis based on that. So churn is a very common problem for all companies. And PayPal was, of course, among the companies that face a lot of churn. Particularly what it was concerned about is churn among its merchant population. And the common reaction for a data science team when we hear about churn is to develop a propensity model that is going to predict the probability of churn for each one of the accounts. And that's exactly what the data science team actually ended up doing, creating a propensity model. When I initially saw this propensity model, I was really impressed because by any statistical measure, it performed very well. It had a low level of false positives and false negatives. and it was substantially better in terms of its accuracy relative to any previous propensity models developed. It was presented to the executive staff, it was celebrated, and then put on the shelf and never used again. So the question is, why, with that kind of accuracy, why would you actually set aside this model and never use it again? Well, here's what happened. When the data science team developed this propensity model, they looked at all of the merchants, that is all of the customers who have received a payment, and created this propensity model without actually thinking about the treatments that would be used to prevent churn for the customers. And what happened as a result is they included a number of customers in the population of these accounts who are not really frequent sellers. They're people like you and I who maybe sold something out of our garage on eBay and don't really have a continuous need to use PayPal for processing payments. So we're not really an addressable population, number one. Number two is we are not really very valuable as sellers. So any kind of treatment that would be deployed to incentivize us to sell more, whether it is a phone call or any kind of coupon, is not likely to be an ROI positive investment into our selling activity. So that was the first issue. The definition of the problem and the choices were not really understood when it comes to the type of population where the treatment would be ROI positive. The second issue is that the team looked at data from 1 year, let's say 2010, and did a prediction of churn in the following year, in 2011. Now, the problem is that many of those customers who were included in the active population in 2010 perhaps stopped transacting back in February or March of 2010. So when you come around to January of 2011 and you are recommending that we focus on a particular subset of customers who have a high propensity of churning, well, of course they have a high propensity of churning. They never really churned. In fact, they churned many months ago. And so it's too late actually to action on that information. Your model is quite accurate, but it is not actionable. Now contrast that with a different model that we developed for sales outreach efforts at Hotwire. So how does Hotwire work? How many people have used Hotwire? Just a few of you. Well, okay, a few shy hands going up. So Hotwire provides incredible savings to customers of up to 60% on hotels, on cars, and also sometimes on flights. And the way we do it is we source inventory from hotels and car companies. So we call up hotels and ask them to load up inventory into our systems and tell them that there is a lot of demand for those hotel rooms for a particular time period, particular neighborhood. So they're going to see lots of sales if they do load inventory into our systems. Now the challenge is that we work with thousands, tens of thousands of hotels, and we have about 40 salespeople working in our sales department. So how do you actually choose which one of the hotels to call at a particular time? The way we approach this problem is by looking at a short period of time, focusing on the upcoming week or couple of weeks. And we'll look for gaps in our inventory where we see significant demand coming in based on the search that we see on the side. And at the same time, we see that there is not enough supply for those dates. And then we can translate that into dollars. What would we get in dollar terms if we actually get more inventory from those hotels? And once you translate it into dollars and can compare it to the investment required to actually get that inventory, then it becomes a choice. Then it becomes a propensity model that is focused on the right business problem and the right choices. Now, the next step for this could be to use Salesforce data on how many of our sales agents actually called up hotels and what was the success rate for those phone calls. And you could incorporate that data so that you not only look at the value of getting that particular account, getting that particular hotel to load inventory for that range of days, but you can also incorporate the probability of success such that you prioritize opportunities even more precisely. The second principle is de-averaging. And de-averaging beyond the first order. So beyond the regressions that we would usually run at the first order to find different coefficients for different variables. I'm going to give you a cost management example, which is not from e-commerce, but I really wanted to share this example with you because healthcare is really on everybody's mind these days. It's such an expensive problem for the nation, and we don't really know how to solve it very well. So when it comes to healthcare costs, one of the leading problems there is people not taking their medication on time. People not taking their prescribed medication. And that results into additional hospitalization when people don't take their medication. And of course, increases the overall expenses for our government and for our healthcare providers and insurance companies. So McKinsey partnered with Beyond Court to understand what were the key drivers for not taking medication. So imagine a regression that you put together and you look at a variety of variables, you do a kitchen sink regression, you look at gender, you look at age, and a variety of other variables. Two of the variables that seem to be really important were gender and age. So women tend to be better at taking medication than men are. And older people tend to be worse at taking medication than younger people. Now, this is not a very actionable finding. You can't go after older men and ask them to take their medication on time. You can't really go after old people and ask them to take their medication on time. You need to start looking for subpopulations that are outliers in terms of the amount of frequency that you see, the level of frequency that you see for that kind of behavior, and also the amount of cost associated with that. So if you look at a decision tree, you start pulling away certain branches. You might prune away women. You might decide, I'm not going to go after that. What is really important for me is the man. You might prune away age, and then you'll go down the branches that are related to men and older people. But when you look at all of the different permutations and combinations, you might actually find certain counterintuitive sub-branches. And here's what they found. They found that young women who have diabetes actually are really bad at taking medication and result in enormous costs for the medical providers. Any guesses why this happens?
They don't want to believe that they have diabetes and they're too young to have that. It's a particular kind of diabetes, it's called.
That might be part of it. Any other guesses? They're too broken. Okay. Any other guesses?
They like sugar.
They like sugar? You can still have sugar and don't take your medication. And actually, you're onto something. They like sugar, but they don't want to gain weight. They want to look pretty. And so if they don't take their medication, they're not actually converting that sugar into extra fat. And they're happy, no extra weight. The problem is you lose weight, but you also can lose an arm and a leg. That's not the outcome that you want to go for, and that's not the outcome that the doctors want to encourage for these young women. So when McKinsey went to doctors with this kind of finding, at first, of course, doctors were scratching their heads, like, women are good at taking medication, young people are better at taking their medication. But what they realized is really that connection to weight loss. And now you can actually have a much more tailored message for young women with diabetes, highlighting for them the type of horrors that they will go through if they don't take their medication, and highlighting for them the frequency of hospitalization that they're likely going to see if they don't take their medication. So that's one example. Go ahead. Where is the problem? So the problem from a statistical point of view is not looking at second order, third order, not looking at those subgroups and discarding branches too early because you have identified that, let's say in this case, gender and age take you down a particular path. And then from, of course, the cost point of view, that's the healthcare costs is something that we, that
the hospitalization cost is the problem.
Mhm.
So
That's
this
right.
is creating the problem. The suppliers, Johnson, for example.
I wouldn't say so. I think that Johnson & Johnson and
Instruments purchased by the hospitals, they are very expensive. If you pay surgical instruments, which is provided by the suppliers of Johnson, they are so expensive.
absolutely, you could definitely.
One example.
Yeah, and there are a lot of very interesting studies on this matter. Intuit actually has done some interesting work with healthcare providers managing down the cost, because what they have found is that, sorry, it isn't Intuit, it is Intel. What they have found is that a lot of the medical providers are actually bad at supply chain management, whereas some of the semiconductor companies are actually really good. They excel at supply chain management. And so whether it comes to suppliers hiking up the prices or just a very inefficient supply chain, a lot of those problems can be also managed through a variety of tools and cross-pollination from one industry to another. In this particular case, what the analysis focused on is really customer behavior and the costs that can be controlled by altering customer behavior.
Just on that, we just see there are some intelligence companies, for example, and the main investors are suppliers, not the hospitals. That's a very important.
Yeah.
Question?
Go ahead.
And if you want to defer this to Ian, that's fine. That's going to wait for that's relevant. When you talked at first about narrowing your focus to make sure you were going down the right track, what kind of process do you go through to determine that focus in the first place? Because it seems like that in and of itself is a data science exploration to determine whether that focus makes sense. And then once you start narrowing your data sets, as you cascade down and you're trying to do root cause analysis, and you don't want to discard the second and the third level factors, especially as there's a growing number of data sets available for you to look for correlations and signatures, what type of process do you go through to engage that data in mining through to get the results that you want?
Yeah, so the first and the second principle can be seen as simply conflicting with each other. But you want to prune the set of treatments, choices that you're trying to look at, versus you are looking at a variety of factors that might be influencing a particular outcome. Those two can happen in parallel. The second one involves broader exploration with tools that enable you to do that broad exploration without making a significant investment into actually doing hypothesis analysis. So tools that can actually enable you to explore a variety of hypotheses simultaneously in an automated fashion. The first one really is about the data scientists or business analysts working very closely with the business stakeholders to understand the realities of the business, to understand the hypotheses around the treatments that can be done to deploy, to address that particular problems that we're surfacing. So some of the treatments that the business stakeholders may come up with, in the case of churn, is picking up the phone and reaching out, or providing different incentives programs. And once you have that kind of set of choices, potential treatments that you could deploy, you can actually then focus your analysis on specifically those types of treatments and hypotheses. So customer acquisition, here's saying from the early 20th century, but it's true as much today as it was in the early 20th century. We're using a lot of digital channels to track our customer acquisition investments, and so we do have the breadcrumb trail to actually understand where the customers came from. But still, it is a very big problem to understand how do you attribute credit to different channels. And also, very importantly, even once you attribute credit to different channels, where do you place it in terms of the type of customers that you are going after? So here is one example, again, talking about first order analysis versus going beyond first order analysis. Let's imagine you ran a regression to understand the value of different customers, and you identified that some of your customers, let's say your young people, are very valuable. Here, young people are represented by people who are taking selfies. And then you figure out that if you look at the state, that's also an important variable when it comes to the value of your customers. So looking at those coefficients, you may decide that you're going to do a Facebook campaign in Florida so that you can attract young people there, and they're going to be a very valuable demographic. But if you go beyond that first order analysis, you may find that actually that subset, Florida young people, is completely unprofitable. Maybe it's all the people in Florida who are actually pushing up the Florida averages. And it's really the New York young people who are quite valuable. So you flip actually the direction of the targeting for your campaign to focus on New York young people via Facebook versus going after young people in Florida. So again, an example of de-averaging beyond the first order, where you may take a very different action based on that finding. And the third one is don't trust your historical data if you can avoid it, and experiment and learn instead. And this is another example where actually you need to work very closely with the business stakeholders to make sure they signed up to do these experiments. And I'm not asking you to do something that is impossible, that is extract insights just based on the historical data. One of the areas where experimentation is really critical is marketing efforts. And it's particularly critical for the type of marketing efforts that may come later in the funnel, such as retargeting, where the customer has already expressed a lot of interest in your product, has done already search on your website for a particular destination or for shoes, and so therefore exhibited a lot of interest, has a high probability of converting. Now, what happens with a lot of the attribution models? With a lot of the attribution models, you use some kind of last touch or restricted last touch methodology, or maybe partial attribution methodology, where you give a lot of credit to that retargeting touch without really thinking about how incremental it is. And if you look at just your historical data, it will be very difficult for you to extract the incrementality information from it. Similar coupons, and this is a problem that we encountered at Hotwire. Hotwire was using a number of coupons. Coupons for the refer a friend problem, coupons to encourage people to download our award-winning mobile application, coupons through different affiliates like Retail Minute and so on. And so then the marketing department came to us, to the analytics team, asking us to decipher what is the impact of each one of those coupons and which coupons they should continue. Now the challenge is that if you look at that historical data, you have multiple campaigns going on. Moreover, you actually have some of those campaigns leaking into unintended channels. So for example, even if you try to set up a campaign where you were sending some of the coupons through email to some of the customers and not to others, if you don't set it up correctly, you may have leakage where those same coupons are getting posted on affiliate sites like Retail Minute. And so that pollutes your experiment. This is an example where we really want to use experiments and ensure that there is very little leakage so that you can actually do a comparison between the control markets and the test markets and really understand the incrementality of these efforts, such as different retargeting investments as well as different coupon investments.
How do you prevent leakage?
How do you prevent that leakage? It's actually a product effort. So one of the problems with coupons in particular is that you may be able to use the same coupon code. So one of the solutions there is to limit the number of users for a particular coupon code. That is to issue individualized or really one-time use codes to different customers. That's one solution that you could use. Another solution that is not very clean, but at least it helps you mitigate the problem, is to limit the duration for that coupon. So don't open it up to 3 months, or it can be used for 3 months and by a variety of users, but you can limit the duration such that you limit the pollution for your control set. That's right. It only limits the pollution. It doesn't actually eliminate it completely. Whereas the one-time use coupons will actually eliminate that problem. There's a question in the back.
The question kind of related to this is, how do you deal with the competitors matching your coupons?
Yes, it's a good question, because what is also happening at the same time is there's this variable that you're not entering into your calculation. The incrementality of these coupons might be very different depending on whether your competitors are running coupons at the same time. So to the extent possible, it would be also good to incorporate information on competitive activity, at least in a qualitative manner, to continuously run the experiments so that you can see the incrementality of your coupons during the times when your competitors are running or not running competing coupons.
I'm not talking about your competitors using your coupons.
You cannot do that.
No, I'm just saying you bring anybody's coupon, I will take it.
Sure, yes. That's another challenge that can happen. We haven't seen that as much in the e-commerce space, but yes, in the offline space, you occasionally see that as well. And then another area where you can use experimentation to a great degree is pricing. Now, it's not possible in every industry or for every company. So even within e-commerce, if eBay or PayPal try to do some experimentation pricing, that will be a big challenge. So in the case of eBay, of course, the pricing that it puts out to its sellers needs to be relatively static. If you're selling something on eBay, you don't want to be surprised by a new set of fees. So when eBay rolls out changes in their pricing, they need to announce it very clearly, and very often we see some backlash to those pricing changes. Similarly, on the PayPal side, PayPal actually made its name in simplicity. So it introduced a lot of simplicity into payment processing, and therefore cannot really dynamically change the fees on its merchants. But in the case of Hotwire, the way we source inventory and the way we actually derive the prices that the consumers see does enable a lot of dynamic experimentation. So what happens for Hotwire and for our competitor Priceline is we get discounts from hotels. This is just an illustrative distribution in terms of the level of discounts that we get from our hotels. And of course, discounts depend on the economic conditions. If the economy is better, we won't get as many discounts because hotels don't have as much leftover inventory. Holidays, conferences, whether there's some additional capacity being built in a particular region, and how good the hotel is at yield management. All of those factors feed into the level of discounts that we get. So now you get these different discounts, and you need to choose what kind of pricing to set up based on these different discounts. The best way to do that is to do some experimentation. So you experiment with different levels of markups. And then look at how well those markups perform for different discounts and maybe other factors, maybe different star ratings, different price points, allow for a different type of markup and to ensure that you are maximizing your revenue. And that's what Hotwire does. We continuously experiment with the markup levels. But of course, at the same time, we have some boundaries. We need to make sure that when it comes to our competition, we are looking at the level of markups that our competition sets. And we need to look not at just the immediate conversion that we see for these prices, but also at the long-term effects of changing our prices. And so in summary, there is really three principles that I would recommend focusing on for any kind of data science and analytics efforts. And that is, first of all, to understand and evaluate your choices. And as we talked about it, a lot of it involves working side by side with the business stakeholders to really understand the problem. As you remember the earlier quote that I mentioned, but also Einstein's quote about spending 55 minutes, half an hour to define the problem before you spend 5 minutes to actually solve it. It's really important to actually understand the choices that you are facing and the problem that you are trying to solve first. The second part will be the averaging, and the averaging beyond that first order so that you can find subgroups that you can target. And there are lots of tools nowadays that enable you to target customers in a very precise way. Companies like Adara enable you to access digital audiences that fit your specified criteria and are lookalikes of your most valuable customers. Hulu, Facebook, Google has become much better at also enabling you to target customers. And a lot of our efforts around unbranded SEM have been successful, particularly because we have been using this information available through Google, particularly mobile searches, to target customers who are most valuable. And then finally, there's this filtering the historical data. And that's something that, of course, requires working again closely with your business stakeholders to make sure that they are comfortable with experimentation. And they will sometimes put up a fight. We definitely have seen a lot of resistance to experimenting with, for example, our investments into retargeting efforts. The ROI for those retargeting efforts, on the face of it, looks really good. And so the marketers may be very reluctant to actually experiment and find out just how incremental those investments are. But as you work at the CMO level, as you talk to people who actually own the overall marketing spend and can help make the prioritization decisions for that marketing spend at that high level, they want to know the answers. They want to know where the investments are not performing. And of course, shop with Hotwire. We have great discounts, particularly on the app.